Okay, we're going to go ahead and revisit the experiment where we looked at the number of digits that students and how much time it took them. So here we have 10 digits for this student. It took them 7 seconds, 29, etc. And last time I taught you how to do a line of regression for that. So let me go ahead and get over here out of the glare. And I have my data entered in the table. And I go stat, calc, linreg, like linear regression, that's number 4. This calculator actually shows the list. So there's list 1, list 2, and calculate. All right. Now, if you don't see r and r squared, that means that you forgot to have the diagnostic on. Someone did a memory clear or change the batteries. So you go second and 0. Scroll on down until you get to diagnostics on. Hit enter and enter again. Now hit stat calc, line reg, and now I can see R. So if I ask you for the least squares linear regression line, I'm actually asking you for this AX plus B line, where A is 0.369 and B is 2.6. So I'll go ahead and write that down here. The line for our model is 0.369, if I do it with y, x plus 2.6. Now, it's usually better to use the terminology that we're having. In this case, we're predicting time. So I could say time, remember the hat means prediction, is 0.369 times the number of digits plus 2.6 seconds. All right, so there's the model there. And the correlation coefficient, if I look at it, it's just the R, 0.984. 0.984. So is that a pretty good fit? Actually, we would say that's a very good fit. Have a number line here, looking at R. Strong fits, right here, is considered strong. There and there. Okay. This is considered moderate. And this is considered weak. So from -1 to -0.8, and from 0.8 to 1 is strong, -0.8 to -5, and 0.5 to 0.8 is moderate, and then between -0.5 and 0.5, including 0, is weak. Now the science actually tells us the direction of the correlation. So all of this is negative, so it has a negative direction. That would be like a negative slope on your line. All of these will be positive. All right, just to remind you how the correlation coefficient looks. So it looks like we have a strong and positive. Correlation. So there's a positive direction. Okay? Now, I want you to be able to take your line then and make predictions. So to make predictions, we're going to go ahead and predict for 10 digits. So I'll take my line right here, which is time, is 0.369 times digits plus 2.6. And I'm going to actually, for 10 digits, I would put 10 in there. So my prediction is time equals 0.369 times 10 plus 0.26, no, 2.6, excuse me, which is 6.29. So my predicted value up here, I'm going to say predicted time in seconds for this one. Now I can go ahead and enter 10, 20, 30, 40, 50, and 60 and do all my predictions for that. Here's a cool thing you can do though. Since I know my model here, right, I can actually go into my data. I'm going to create a third list for my prediction. You go all the way up, so where this is black, and you put down, oh, it's going to be, this list will be 0.369, and what do I have to multiply it by? The time. Time is in list 1. So I'm going to say times list 1 plus 2.6. And look at that. I have all my predicted values. 6.29, 9.98, 13.67, etc. So that saves me a little bit of time when I'm trying to predict a bunch of residuals. A bunch of predicted times. Which brings me back to what I just said, which is something called a residual. So what is a residual? A residual is basically your actual minus your predicted. So it's basically how far above the regression line. If I were looking at the regression line for my old data, then it would be how far above the line my actual point was, or how far below. Here, am I above or below the line? I'm above the line, aren't I? So to do it, I just go actual minus predicted. So I'm going to do 7 minus 6.29, and I will get 0.71. Guess what? I can use the shortcut of the table. Again, hit Stat, Edit. I'm going to go to List 4, and I'm going to calculate my residuals. By the way, your calculator automatically does the residuals, but this is still pretty cool. So I'm going to say it's List 2, which is my actual, minus my predicted. All right? So that would be List 2 minus, enter, and there are all my residuals. See, there's the 0.71 I got earlier. So I have negative 0.98, 1.33, negative 1.36, negative 1.05, and 1.26. So this is my actual points above, and here it's below. Now here's the weird part. The question is if we're over or under predicting. Well, when my actual point's above the line, right, that means the line's predicting this part right here. And here's my real point. When it's above the line, my line's under predicting. So under predict. So it's the opposite of where it is compared to the line. So this tells you where it is compared to the line, and this is where it is for predictions, which is the opposite. All right? Now that I have all these residuals, I can actually plot them. So I'm going to kind of scroll this up, and you can see I've already started a residual plot here. So the first point at 10 digits was 0.71. So that's roughly about here. Then we have negative 0.98, which is almost here. 1.33, which is roughly here. Negative 1.36, which would be about here. Negative 1.05, which would be just over, negative, forget that, sorry. Negative 1.05, which would be about here, and 1.26, which would be roughly there. This is, you can see there's no real pattern. So, no real pattern. Looks like random dots. That's good. All right, that means we can use linear regression provided R is moderate or strong. Okay. If R is 0, obviously this won't work. Now, the other problem, you will get a problem if you do get a pattern. So, first of all, actually your calculator can also graph your residuals. So if you go second stat plot, I'm going to turn on the first plot. And this time, normally we have X and Y, so I can see my original. If I hit graph, then I'll have to hit zoom and 9. Zoom, 9. Did I hit, let's see, second stat plot. It helps if you turn your graph on. Graph, zoom, and 9. There they are. So that's what my plot looks like. That looks pretty good for a line, actually. Now, you can actually do your residuals. So you go second stat plot, and instead of doing your Y value, which is list 2, believe it or not, your calculator generates the residuals when it does the fit. So I can change it to list 7, which is residual. I did second stat plot, go down to list 2, and then change the list there, 7, and then hit graph. Now, for some reason, the calculator slows down when you are doing residuals, so I'm going to hit zoom 9, and there are my residuals. And hopefully, you'll notice that those dots look a lot like my dots that I graphed. So that's very good. Now, I'm going to go ahead and play with the times a little bit so that I know that they're actually going to be a little bit curved. All right? So what I'm going to do, let's see. Let me go ahead and play with this. So we'll do 17, 18. All right? Let's pretend that was the data, and I'm going to do a linear regression. Calc, line reg, everything's the same. And I still get a pretty darn good linear regression. But if I go stat plot and graph, hopefully you're going to see more of a pattern. Let me do zoom 9. See that pattern there? That's a bad sign. So that tells you there's something that you have to be careful with your residuals. Maybe there's something else going on. So that would actually, let me go ahead and do a normal plot. Get rid of the residuals. All right. And make that list 2. So this is just the normal graph. And I have to hit zoom again. The normal graph, you might say, hey, that's okay. Well, what this is really telling you is it's actually seeing a different linear relationship from here. So this is the overall it's calculating, but it's going, wait a second, there's a pattern here that doesn't fit the line we had. So when you do see a pattern, pattern is bad. All right? Be careful with linear model. Probably don't want to use it. All right? Should say avoid. And that's residuals.